All right, let's jump right in. Today, we're going to talk about a pretty amazing climate solution that's been hiding in plain sight right along our coastlines. It's a story about a massive carbon secret and how we might just be able to unlock it.
So, what are we talking about here? It's a concept called blue carbon. And put simply, it's just the massive amount of carbon that gets captured and stored by our coastal ecosystems. And you're going to see why it's getting so much attention right now, for a really, really good reason.
At the heart of all this are three incredible ecosystems. You've got your mangroves, right? These amazing trees that can live in salt water. Then you have tidal marshes, those grassy wetlands we see all over our coastlines. And of course, seagrasses, which are basically these huge underwater meadows. These are our blue carbon heroes, and wow, do they punch above their weight. I mean, get this. They can bury carbon in the soil up to 40 times faster than a mature tropical forest. But, and this is a huge but, there's a major problem. These ecosystems, which are phenomenal at locking away carbon for literally centuries, are disappearing, and the rate at which we're losing them has some pretty staggering consequences.
For hundreds of years, human activities, things like building cities or converting land for agriculture, have been slowly chipping away at these vital habitats. In the 20th century alone, we were losing them at rates as high as 1 to 3% every single year.
And this creates what you could call a dangerous double whammy. See, when we destroy these ecosystems, they don't just stop sucking up carbon. Oh no, they release the massive amounts of carbon they've been storing for centuries. So they flip from being a carbon sink to a carbon source, spewing millions of tons of CO2 equivalent, which is just a way of lumping all the greenhouse gases together, into the atmosphere year after year.
Okay, but here's the incredible flip side to that depressing story. Every single bit of that loss actually represents a massive opportunity. Because what if we could not just stop the damage, but actually reverse it? What if we could bring these powerhouse ecosystems back to life? And that right there is the core idea behind blue carbon restoration. This isn't just about passively protecting what's left. It's about actively getting in there and rebuilding these habitats with the specific goal of supercharging their ability to fight climate change. And the scale of this opportunity, it's just staggering. Scientists figure there are about 30 million hectares of degraded coastal land worldwide. We're talking an area roughly the size of Italy that could potentially be restored. And the vast majority of that potential, it's in former seagrass and mangrove habitats. So here's the payoff. If we actually did this, if we successfully restored these areas, they could pull more than 840 million tons of CO2 equivalent out of the atmosphere every single year. To put that in perspective, that's like taking almost 200 million cars off the road permanently. That is a genuinely significant climate impact.
Okay, so the potential is huge. It sounds amazing on paper, but does it actually work in the real world? What happens when we really put shovels in the ground or seeds in the water? Let's look at the evidence. Well, when we look at mangroves, the results are pretty clear. The trees themselves, the stuff you see above ground, they bounce back pretty quickly. They show really strong growth for about 15 years. But the real treasure, the carbon that's locked deep in the soil, that takes a bit longer. It can take, 2 or even 3 decades for that rich soil to build back up and match what you'd find in a natural, untouched forest. Now, with tidal marshes, this is where it gets really wild. The results can be stunningly fast. Studies show that a restored marsh can store up to 3 times more carbon in its soil than a degraded one. And what's just incredible is that this can happen in as little as 4 years after you start the restoration. Just 4 years. And for seagrasses, there's this fantastic long-term restoration project in Virginia that gives us all the proof we need. Now, it takes a few years to really get going, but after about a 5-year lag, the rate at which carbon gets buried in the sediment literally doubles. And by year 12, these restored meadows are working just as hard as a mature natural one. The engine has been completely restarted. So the science is solid, the potential is enormous. This should be a total no-brainer, right? Well, this is where we hit the messy, complicated reality on the ground. The hard truth is, a lot of restoration projects, they fail. Not because the biology is wrong, but because the execution is just incredibly difficult. That shocking statistic you see there from Sri Lanka, that's not some weird outlier. It's a huge cautionary tale about what happens when these projects are done poorly. And failure often follows this really predictable pattern. It starts with social issues, like no one's really sure who owns the land. That leads to political decisions, right? Someone sets a simple but really misguided target, like, we're going to plant 1 million trees, which forces managers to just find any open space they can. And that leads to the final step, planting seedlings in places that are just wrong. The water's too deep, the elevation's off, and the project fails. So this really shows you the huge gap between what's possible and what's practical. A study in Southeast Asia found this massive amount of land that was biophysically perfect for mangrove restoration. But once you factor in all the real-world stuff, land use, cost, politics, only a tiny fraction of that was actually realistically available. But look, these challenges aren't a dead end. They're not a reason to give up. They're a roadmap. They show us that we need to get a whole lot smarter about how we do this. Let's see what that smarter path forward actually looks like. The big shift we need to make is from what you could call an opportunistic approach, just planting wherever it's easy or cheap, to a truly strategic one. This means instead of focusing on a simple number, like how many seedlings you planted, the real goal becomes long-term survival and function. And instead of picking a location just because it's convenient, you pick it because the science says it's the right place.
And this is how we get strategic. We have these seriously powerful computer models now that can analyze all the critical environmental factors: salinity, elevation, water flow, even what future sea level rise might do. And with all that data, they can pinpoint the exact locations that have the absolute highest probability of success. It's about taking the guesswork completely out of the equation.
So let's just boil all this down. What are the big takeaways? 1, our coastal ecosystems are these massive, incredibly important carbon storage powerhouses, and they're under threat. 2, restoring them is a powerful and scientifically proven way to fight climate change. But 3, and this is maybe the most important part, the biggest barriers we're facing right now aren't biological, they're human. And the only way we're going to overcome them is with smart, strategic, science-led planning. Which really leaves us with this final thought. The question isn't about the science anymore. We have the tools, we have the knowledge to make blue carbon restoration a massive success. The real challenge now is whether we can align our policies, our funding, and our collective will to finally get it right. Our blue carbon future really depends on it.